So, Jai Hind everyone, myself Dr. Vishwas Grover, Assistant Professor in Mechanical Engineering Department, Ajay Kumar Garg Engineering College. So, today we will talk about this subject, that is the renewable energy resources, and its code is ROE 086. So, we will talk about all these things and what are these. And first of all, in introduction, first of all we will look after the entire syllabus, what is that syllabus and how this is been strategically classified. And first of all, in this PPT we will see over the brief introduction about, first of all we see the this syllabus, and then the brief introduction about the topics of these. Okay, brief introduction about the various topics of this renewable energy sources. So, in unit 1 we can see that these are the various non-conventional energy resources, its introduction, availability, classification, relative merits and demerits. So, this is constituted in this unit 1. Then after this there are the solar cells. Then theory of solar cells, what are the solar cells, we will look after it. Then solar cell materials, then solar cell array, solar cell power plants, and then their limitations. So, these are the unit 1, this is constituted in unit 1. Next is the solar thermal energy. Solar thermal energy is solar radiation, flat plate collectors and their materials, we will look after these. Then applications and performance, then focusing of collectors which collect the solar power radiations and their materials, then applications and performance, then solar thermal power plants, thermal energies, storage for solar heating and cooling and their limitations. So, these are the this is constituted in this unit 2, that is the solar thermal energy. Third one is the geothermal energy. Then these are the resources of the geothermal energy, thermodynamics of geothermal energy, conversion, electric conversion, non-electrical conversion, environmental considerations. Okay. Okay. So, environmental consideration, then magneto-hydrodynamics. This is one of the type of this generator which we can observe or see. Then principle of working of MHD power plant, performance and their limitations. So, these are the magneto-hydrodynamics. Then there are fuel cells. Fuel cells in this is also a very interesting topic. So, in this principle of working of various fuel cells and their working and their performance and limitations, we can see that. And then in unit 4, these are the thermoelectric and thermionic conversions, the principle of the working, performance and limitations. Then wind energy and its sources, site selection criteria, momentum theory, classification of rotors, concentrations and augments, wind characteristics, then performance and limitation of energy conversion systems. So, this is constituted in this unit 4. Next is the unit 5. Unit 5 is the biomass, that is the availability of the biomass and its conversion theory. Then ocean thermal energy, that is OTEC. This is also very interesting topic, OTEC, ocean thermal energy conversion, its availability, where this ocean thermal energy is situated, where we can find this, and then the theory and its working principle, then performance and its limitations. Okay, then wave and tidal wave. What is the wave and tidal wave? Then principle of working, performance and limitations of this wave and tidal wave. Then waste recycling plants. So, this is in the unit 4. So, these are the reference textbooks which we can refer, that is the Raja et al., that is Introduction to Non-Conventional Energy Resources. This is the Science Tech publication. then John Tweedu and Tony Ware, that is the Renewable Energy Sources, BSP publication 2006. So these are the different textbooks which we can refer for. Okay. Then next is the, first of all we will start with the contents of the unit 1. In the unit 1, in the introduction, we will discuss about the various non-conventional energy resources, availability, classification and relative merits and demerits of these non-conventional energy sources. Then after that, solar cells we will talk about. So first of all, we will need to learn what is energy. Can you please tell me what is energy? So energy is the energy of a body, is its capacity to do the work. Means capacity of a body to do the work is called its energy. Then it is measured the total amount of work that the body can do. Means what it is the measured the total amount of work that a body can do or can perform, that is the energy. So energy is the primary and most universal measure of all kinds work by the human beings and the nature. So this is the energy. So energy is the primary and most universal measure of all kinds of work by the human beings and the nature. Then everything what happens in this world is the expression of flow of energy. Means everything which occurs in this planet is just because of the flow of the energy in one of its form. Means energy gets converted, that is chemical energy gets converted into mechanical energy to result out some things. Okay, so everything which happen in this country or in this world is due to the conversion or the flow of the energy from one form to the another form. Okay, so the energy sources available can be divided into 3 types. First are the primary energy resources. Okay, primary energy sources which are available. Then secondary fuels which are available. So we need to learn how these secondary fuels are there. Then supplementary sources, different supplementary sources are there for the energy sources which we need to learn. Then first of all we will look after the primary energy sources. Means the energy sources from where these can be obtained, those are the primary energy sources. So primary energy sources are those which provide a net supply of energy. Okay, which gives the net supply of energy are called the primary energy sources. Okay, the energy required to obtain from these fuels is much less. Means so to extract that energy, so the energy which is required to obtain from these kind of fuels is much less as compared to which can produce by the combustion or the nuclear reactions. Means in the combustion, in the reactions where the combustion takes place or the nuclear reactions takes place, the large amount of energy gets required. But in this primary energy sources we can extract out in a very with applying a little force. So that is the primary energy sources. So the primary fuels only can be accelerate growth, but their supply is limited. Primary energy sources are available manywhere, but their supply is very limited. Example like coal, natural gases, oil and nuclear energy. These are the examples of where the primary energy sources are available. Then next are the secondary fuels. Secondary fuels means alternate fuels other than the primary energy sources. So secondary fuels are those which produce no net energy. Means no net energy is obtained even though it is necessary for the economy. Means the energy comes from it, but no net energy gets formed, like the solar energy, wind energy. In this these are not the primary energy sources, but these can be formed. Solar energy, wind energy, geothermal energy, etc. The conversion means net energy cannot be obtained in these. Okay. Then next are the supplementary sources. Supplementary sources are defined as those whose net energy yield is 0. Okay. Net energy yield, whose net energy yield is 0, and those requiring highest investment in terms of energy. Okay. For those which require highest investment in terms of energy. For example, the insulation energy means the energy required for insulating the some things are called the insulating energy. Then next are the different forms of energy. Different forms of energy are like mechanical energy, in which the kinetic and potential energy, which we have already learned in these previous classes, or like these. There are the kinetic energy or potential energy. Potential energy is the energy which is stored in an object due to its height, and kinetic energy is the energy which is stored inside an object due to its motion. That is the half mv square kinetic energy. So these are the mechanical energies. Next is the thermal or the energy conversion. What are the thermal or energy conversion? Thermal or heat energy means the energy which is stored in the form of heat is called the thermal energy or the heat energy. Next is the chemical energy. Chemical energy is the energy which is stored inside a body, okay, which is stored inside a body due to its chemical composition. That is your chemical energy. That this is your chemical energy. Then next is the electrical energy. What is the electrical energy? Electrical energy is the energy which is stored means due to the electrical conversions inside in a body. That is the electrical energy. Next is the nuclear energy. Nuclear energy is the energy which is produced due to the in substances in which some reactions takes place. That is the nuclear fission or fusion. Due to that, this energy comes out and we can utilize that. Then next is the electromagnetic. Electromagnetic is the energy which is stored inside the electromagnetic means the when the coil is rotated inside the magnetic field, then electromagnetic force gets generated out. That is the electromagnetic energy. Then gravitational energy is the energy which pulls an object, which pulls an object. That is your gravitational energy. Okay. Then next are the energy sources and their availability. Today every country draws its energy need for a variety of sources. Means, as all you know, everyone in this country or different country requires the fuels or the energy sources for their different purposes, like for having this electricity or for running the more automobiles, and different kind of energy forms are required. So we can broadly categorize these sources of energy are into commercial and non-commercial. Okay, commercial sources include the fossil fuels like coal, oil and natural gas. These are the commercial sources where these are available. Commercial sources in which these fossil fuels are available. Okay, these are the commercial sources which include the fossil fuels like coal, oil and natural gas, hydroelectric power and nuclear power. While the non-commercial sources include the wood, animal waste and agricultural waste. These are the non-commercial sources. Okay, these are the non-commercial sources. These commercial sources means which are used for the production of energy at a large scale. So these are the commercial sources, and the non-commercial are means we can use this in our day-to-day life, in our normal belongings like your wood, animal waste, agricultural waste. These energies can be utilized as a non-commercial sources. So these are explained like conventional sources energy these are accumulated in nature over a long span of time. Two types of energy sources are there. First are the conventional sources of energy which are accumulated in nature for a long period of time and utilized over time. Okay, and cannot be quickly replenished when exhaust. Okay, so these are the conventional energy sources. These cannot be replenished when exhausted. So these are produced over a long period of time. These are known as the non-conventional energy sources, that is the coal, petroleum, natural gas, nuclear fuels like uranium and thorium. These are the different non-conventional energy sources which are produced over a long period of time. Okay, so these are these things. Then non-conventional sources energy are these sources of energy can be used again in an endless manner. Okay, these can be used in an endless manner. These cannot be generated continuously in nature and are inexhaustible, means cannot be exhausted. Okay, and these can be generated continuously in nature like solar energy, geothermal energy and wind energy. These are produced over a period of time. So these are the non-conventional energy sources, okay, which can be used again in endless manner, which can be used again and again. Like solar energy, we capture through the solar power plant, solar panels, then can be utilized, and then we can recapture these things. Okay. So these are the different pictorial diagram of this renewable energy. Renewable energy are like the energy sources like wind energy, geothermal energy. This wind energy can be converted to for our as energy source. Then geothermal energy can be converted, hydropower energy can be converted, solar energy can be converted. So these are the renewable energy. Then biomass energy is like for which where we burn these plants or the trees, and with the burning of these plants we can generate the energy. So these are the renewable energy sources, and these are the non-renewable energy sources where like energy is there. Energy can be extracted from the natural gas, nuclear power plant, fossil fuels. So these are the non-renewable energy sources, or can be coal. Here we can see, we have seen that these are the non-conventional energy sources, where these are the sources of energies which can be used again in an endless manner, can be used again and again and again in an endless manner. So these are the non-conventional energy sources. Then next are the non-conventional energy sources are using energy from sources which cannot be used up, like sun, wind, water and waves. Support the sustainable development by reducing the carbon emission. Okay. So using these energies from the sources which cannot be used up, like sun, wind, water and waves, supports the sustainable development by reducing the carbon emission. This contributes to the increasing energy. Okay. This contributes to the increasing energy and the climate security for many countries across the world. So these are the non-conventional energy sources. And renewable energy resources comes from the sources which cannot be used up, such as wind, sun, water. Okay. Wind, sun, water and waves, rather than the fossil fuels such as oil and coal. So these are the renewable energy sources which comes from the sources, okay, which cannot be used up, such as wind, sun, water and waves. So renewable energy sources are like wind, biomass, solar, hydroelectric, geothermal, wave or tidal energy, which can be utilized in an endless manner, which can be utilized and then again utilized. Okay, so this is the renewable energy sources. Next, conventional energy sources are like energy used for why and where the energy can be utilized. We were discussing like energy can be utilized for heating, cooking, transportation and manufacturing. Means for heating something or cooking or transportation and manufacturing, these energy can be utilized in our day-to-day life. There is nothing different in that, and energy can be generally classified as the non-renewable and the renewable energy sources, which we have already discussed, renewable and non-renewable energy sources. These are the renewable energy sources, and over 85% of our energy used in this world is from the non-renewable energy supplies. Okay, these are the non-renewable energy sources, where we can see that the electricity which comes in our house are due to the burning of the coal or the fossil fuels or the natural gas. Okay, so these are the non-conventional energy sources. Then is from the non-renewable supplies. Most developed nations are dependent on non-renewable energy sources such as fossil fuels, coal and oil and nuclear power. Okay, so most of the developed nations are dependent on the non-renewable energy sources like fossil fuels, coal and oil and the nuclear power. So these sources are called the non-renewable because they cannot be renewed or regenerated quickly. Okay, means why they are called the non-renewable, because they cannot be renewed or renew very quickly or regenerated very quickly, and these requires enough time to keep pace with their use. Okay, then conventional energy sources are like fossil fuels energy, hydraulic energy, nuclear energy. So these are these fossil fuels. Then next is the, so we were discussing about these the various topics of this unit 1. The next one is the wind energy, that is your introduction and its availability. After discussing the conventional or renewable and non-renewable energy sources, we will discuss about this wind energy. So wind power is usually generated by the wind turbines. Okay, how these wind power is generated? Wind power is usually generated by the wind turbines situated either on the onshore of the or the offshore. Okay, how this wind power is generated? Wind power is usually generated by the wind turbines by moving the blades of these large blades of these wind turbines. This wind power is generated, and the kinetic energy of this wind means the rotation kinetic energy of this wind, as here we can see that these blades of this wind power plants gets rotated due to the movement of this. Okay. So the kinetic energy of the wind is measured as a cubic proportion to its velocity and is being used foil centuries in water pumping, like windmills, irrigating fields and navigation. So these can be utilized, wind power. Okay, then wind energy is utilized by means of windmill. How wind energy is utilized? Wind energy is utilized by the means of a windmill. These are the windmills. When this get rotated, this wind energy gets generated. So wind energy is utilized by means of a windmill. Many projects on the windmill system for water pumping and for production of small amount of electrical power have been taken in this our country. Like these are the different projects which have been installed for capturing this wind energy, like Sezri windmill at Jodhpur, Rajasthan, WP water pumping windmill by NAL Bangalore, MP1 Sail windmill at NAL Bangalore, then windmill at Central Salt and Marine Chemicals Research Institute, Bhavnagar, that is in Gujarat. Okay, then 12 PU 500 windmill at NAL Bangalore. Okay, so these are the different projects which have been installed. Okay, then Madurai windmill at Madurai, that is in the Tamil Nadu, and Tyabji windmill at Tilanoya near Ajmer, Rajasthan. So these are the different projects which have been installed. So this is the diagram of this windmill. Then next we will discuss about this merits and demerits of this windmill or wind energy. So certain merits are there, that is this wind energy is available, abundant availability of wind energy is available for the no price. Then useful of remote places, also for the electricity generation, these are utilized. Then the non-polluting and the eco-friendly, these are the resources. Okay, non-polluting or the eco-friendly are there. Non-polluting and eco-friendly wind energy is available and cannot be utilized for the end user, or also such as hybrid energy sources, that is the wind, photovoltaic, etc. Okay, so these wind energy can be utilized for end user also, such as hybrid energy sources, example wind, photovoltaic, etc. Then suitable for power supply at offshore and onshore, such as the hilly region sites. Then cheaper installation cost and almost negligible recurring expenses are there for these wind energy. Then certain demerits are also there, that demerits are less favorable in city locations, because these wind turbines can be placed outside in the outskirts of this every town, where this the motion of wind is available very readily, but these cannot be located in the city location. So less favorable in this city location, these can be the demerits of this wind energy. The wind is available at the higher locations, and it is the unreliable and intermittent, and it is not available regularly. Okay, so these are the demerits. Then flow of wind is not guaranteed throughout the year. means we cannot assure that the wind is available throughout the year, that it is available at the uh, entire throughout the year. So this cannot assure that, therefore its use for continuous supply power station is not feasible. Okay, that's why the use of the continuous supply power station is not feasible. So these can be the demerits of this wind energy. Then due to the fluctuating nature of the wind blowing, the produced mechanical energy has to be stored by some means like battery storage. Okay, so there is a fluctuation of wind blowing, so we needs to restore, means at certain point or at certain time the flow of this wind is very much high. Okay, but after certain time these needs to be so when the flow is not there, so we needs to store these in the batteries. Okay, so these are the battery storage. Then present day wind energy systems are the source of immense noise pollutions, means when the rotors get rotated due to the flow of the wind, the immense noise or pollution gets appear. Okay, so these can be the demerits of this wind energy. Next is the solar energy. So solar energy we will cover. Solar energy as the name suggests, solar energy is the energy which is captured due to the sun. Okay, so that is the solar energy. So solar energy is a clean and abundantly available renewable energy which is available in the open space, that is the solar energy. Then the total radiant energy of the sun is vast. Okay, total radiant energy of the sun is vast, out of which only small fraction gets incident on the outside of the earth atmosphere. Okay, small radiations get impinged on the outside of the earth atmosphere. 30% of it is directly reflected back to the outer space. Okay, 30% get reflected back, and when the incident radiations falls on over this and back to outer space in the short wave radiation, and 47% is directly converted to the heat. Okay, 47% is directly converted to heat, that is lost to the outer space in the long wave radiation, and major portion of the rest 23 causes the evaporation, precipitation and circulation of water. Okay, means 47% is directly converted to heat, and major portion of the rest 23% causes the evaporation, precipitation and circulation of water. Circulation, these give the circulation of water in the hydrologic cycle of this earth. Then sun radiates its energy in all directions. Okay, sun radiates its energy in all directions in the inverse. Sunlight received during the day hours and clear sky has power density of between the 0.5 kilowatt per meter square. Okay, sun radiates, the solar energy gets falls over this, and the sun radiates its energy. Okay, and radiates its energy in all directions of the universe, and then sunlight receives during the day hours, and clear sky has very much power density, that is between the 0.5% kilowatt per meter square, and that range from the 0.5 kilowatt per meter to 1 kilowatt per meter. So solar energy varies with seasonal, geographical location, day and night, etc. So these are the different solar panels which are installed, as we can see in our day to day life nearby. Okay, so these are the solar panels which capture the solar energy and converts the solar energy into the electrical energy. So certain merits and demerits are also there for the solar energy. First of all, we will look after these merits. So it is a noiseless operation because it works in the means it works in the with very less noise. So it is a noiseless operation, and it occupies the less space on the floor, as there is no need to for the storage vessels. Okay, so it occupies the less space on the floor. Then it is a cheaper initial cost, means here it is wrong that wrongly written that that initial cost is very much high, and but so there is no need of containers to store these fuels. Okay, so this is the merit of this solar energy. So in most of the equipment, the maintenance cost is very negligible. Okay, maintenance cost is very negligible, and in most of the equipments do not require any serious attention during their working. For example, food will be cooked simply after putting the solar cooker in the sunlight. This is very much simple, that uh, we can utilize this solar energy in this form. Then certain demerits are there, like solar equipments fail to work in nights, cloudy day or the rainy seasons. So these can be the demerits. Okay, because these in cloudy days these solar panels or these solar equipments does not work properly. Then large space is required for the collection of solar energy at a useful rate, means these the size of these solar panels are very much large. So large space is required for capturing this solar energy. So these are the different merits or demerits. So today we will end up here and will continue in the next class. Thank you so much.